Sender Policy Framework, SPF, is an email verification technique that validates if the server sending the email is authorized to do so on behalf of the specified domain. This verification pertains specifically to the sender indicated in the envelope from field during the initial SMTP connection. If the email bounces, a message heads back to this address, and for subsequent transmission, it typically surfaces in the return path header. To authenticate the email address visible to recipients in the from line, additional technologies like DMARC are necessary. Email spoofing, the falsification of this address, is a common tactic used in phishing and spam emails. The list of approved sending hosts and IP addresses for a domain is disclosed in the DNS records for that domain. The inception of SPF traces back to around 2000, gaining momentum after being reintroduced in 2002 by various contributors. Ultimately, the specification evolved, and in 2004 the name was changed from Sender Permitted From to Sender Policy Framework. Despite an attempt in 2004 to merge SPF with Microsoft's Caller ID proposal under the Merid Working Group, it eventually collapsed due to technical and licensing disputes. Over time, SPF returned to its original version and garnered approval as an IETF experiment in 2005. By April 2014, SPF was documented in RFC 72008 as a proposed standard. SPF operates by permitting domain owners to designate which computers are authorized to send emails from their domain using DNS records. Receivers can then verify this SPF information in TXT records to potentially block messages from unauthorized sources even before receiving the message content. The mechanism closely resembles DNS-based black hole lists, DNSBL, but employs the authority delegation framework of the domain name system. Presently, TXT records are a standard practice for SPF, following the discontinuation of alternative DNS RR types post the experimental phase. The enforcement of SPF policies occurs at the initiation of the SMTP dialog, aiding in the prevention of email forgeries in the return path address. While SPF can identify unauthorized sending domains, it does not entirely thwart the falsification of other addresses, like the sender header. SPF primarily benefits email address owners whose addresses are counterfeited in the return path, reducing the volume of undesired auto-replies they receive. Furthermore, SPF contributes to distinguishing unsolicited emails and enhancing the recognition of trusted senders. By leveraging SPF information, receivers can ascertain known reliable senders using SPF pass results alongside an allow list, though this application is limited in scenarios involving compromised systems and shared sending mailers. Compliance with Sender Policy Framework, SPF, involves several tasks. Firstly, publishing a policy involves domains and hosts specifying the authorized machines to send emails on their behalf by adding SPF records to their DNS information. These records help identify which domains or hosts can send emails. Additionally, hosts that do not send emails should have SPF records indicating so, vchest SPF1 all. Secondly, checking and using SPF information is essential. Receivers utilize DNS queries to interpret SPF information and act accordingly based on the specified policy. Lastly, revising mail forwarding is crucial since plain mail forwarding is not allowed by SPF. Instead, alternatives like remailing, refusing, allow listing, and sender rewriting schemes should be considered. The main focus of SPF lies in the specification of new DNS information by domains and its utilization by receivers. SPF records typically follow DNS syntax with mechanisms like IP4 and A, specifying permitted systems and ending with all to reject messages not meeting the criteria. Qualifiers such as plus, INI, and signify different results when combined with mechanisms. Modifiers like expasum.example.com and redirectsum.example.com offer additional functionalities within SPF policies. Error handling in SPF implementations ensures that syntax errors result in perm-error, while safeguarding the number of DNS queries to prevent long evaluation times. Deployment of SPF has seen adoption by various anti-spam software and mail transfer agents to prevent spoofing and enhance email security.